specify the elasticity and how bouncy they are, and that even you can just define the density of one versus another. So a really dense one will smash another one out of the way. All definable. You can also set boundaries. So any UI Bezier path that you want to come up with, you can put it in your collision behavior, and things will bounce off it. So it could be round, it could be square, whatever, and things will bounce off it when they hit it. Also, you can set the boundaries of the reference view to be bouncy boundaries as well by saying translate reference bounds into boundary equals yes, and then things will bounce off the edges of the reference view, the top level view in the dynamic animator. Okay? So the collision mode determines whether the items bounce off each other or just off the boundaries. Okay? All right. Attachment behaviors. Okay, this is a way to attach an item to a fixed point or to another item. Now, one thing to remember about this, if I hook an item up to a point, that does not mean that item's not going to move. Okay? If I hook it up to this point and I have an item here, right, and gravity happens, my item's going to go like this. It's going to swing, okay? Because the attachment is just attaching the two things, the point and the item. It's not attaching it to the background, okay? And also, if I move the point, the thing will stay with it, and it'll kind of swing around behind it. And we'll see this in the demo, okay? So attachment is attaching the thing to a point. You can also attach two items. If I attach two items like this, and I have gravity down, they're going to go bam. They'll stay the same distance apart, but they're just going to go straight down because gravity will still be applying to them as well, right? And the connection just keeps them together. The attachment behavior is a little different than the other ones in that you don't alloc init. You actually specify the attachment at init time. So alloc init with item, alloc init with other item. There's also some versions where you can attach items where the attachment point, instead of being the center, is offset. And that will make things kind of hang. If the items rotate, they'll kind of tilt, okay, because you're not grabbing them in the middle, you're grabbing them on the side. So you can make some pretty cool effects. The other thing to notice about attachments that's cool is that the length between the two items is writable. So for example, let's say you were pinching, okay? You could change the length, and those two attached items would move closer together, okay? So even though you set it up as this item attached to this point, or these items attached to each other, if you change the length to be smaller, they'll move towards each other. Okay, which is cool. And same thing with the anchor point. If you move the anchor point around, the attachment will still there, and the thing will follow around, right? With other behaviors applying to it. Question?
Is that attachment length, is that an exact value, like it would be with like when they're attached?
Is it like an iron bar, you mean?
Yeah, like iron bar or string.
Okay, so the question is it like an iron bar or is it more like a string? And actually what it is, it's like a spring. Okay, so it actually, as you move it around, like if I move it up, it'll spring up. And you can control the damping and oscillation of that. By default, it's an iron bar. Okay, so the damping and oscillation are set so that it does not oscillate. But you can set it so that as you fall around, it kind of, it's really very cool. So you can play with all those when you are doing your homework. Snap behavior snaps an item to a location, but it does more than just have it fly there. It does fly there rather rapidly, I might add. When it gets there, though, you can imagine that there's 4 springs attached to the item in the corners a little ways out. And so the thing gets there and it goes, kind of springs like this. And you can specify how much it does that. Why does it do that? That's because you want to give feedback to the user, oh, I just moved this. And so you don't want it to just go, blip. You want it to go, you know, and it kind of gives them just a moment's springiness. To, oh, okay, so that's good in animation. So snap behavior, very common. Also, you have push behavior, which is you can push an object and it'll start moving. So especially if you don't have gravity, this might be what causes things to move. You push it and it moves across. And these items have friction. They have density when they collide with each other. So push, you can read about push and how you specify the angle and the magnitude and all that. Okay? So another thing about behaviors is you want to be able to set this friction, elasticity, the density, all these things I was talking about. You want to set them on the items independent of the other behaviors. Okay? So if I have friction, I want it to apply whether it's gravity that's causing the thing to move or whether a collision caused it to move. So we don't put the friction and the density and stuff like that in collision behaviors or gravity behaviors, we put it in its own behavior called the items behavior. So there's a class, a behavior called UI dynamic item behavior. Okay? And so if you want any of these things, like you don't want to allow it to rotate, you don't want the view to be able to rotate, which I don't know, for your homework, sometimes you might want that, sometimes not, or you want to specify the friction or the bounciness of this object, you create a UI dynamic item behavior and add the items to that as well. So the item would be a member of the gravity behavior, it might be a member of the collision behavior, and it's also a member of a UI dynamic item behavior. Okay? And this controls all its options. So you can think of this as kind of like the animation options, but really it's more like the behavior of the intrinsic behavior of that item. Okay? What is its density? You want that to be the same no matter what behavior is acting on it. You can also find out information about what's going on with the item using the UI dynamic item behavior. It has methods like linear velocity for item. It'll tell you the velocity of this item in different directions, which is really cool for if you want to take over animation. The dynamic animation system started this thing moving, and now you want to take over and keep it moving, maybe in some other direction or something like that. You can find out how fast is it moving right now and then continue having it move at that speed. Same thing with angular velocity, how fast it's rotating in radians per second. Okay? Dynamic behaviors also, UI dynamic behavior is the base class for gravity behavior, collision behavior, all these. You can also create your own subclass, and usually when you do, your implementation just adds other behaviors as child behaviors. So there's a method in UI dynamic behavior called add child behavior, and you can add a gravity, collision, UI dynamic item behavior as sub-behaviors. And this is very common to do just to clean up your API, to group behaviors that go together into their own class, okay? Their own UI dynamic behavior subclass. And all that thing usually has is child behaviors and then maybe a little bit of API to add the items in a certain way or have them interrelate in some other way. Okay? What is more, all behaviors, all UI dynamic behaviors, gravities, collision, your own custom ones, whatever, they know what dynamic animator they are in. They have a property called dynamic animator, which is say what dynamic animator they're in. And there's kind of a view controller lifecycle thing of UI dynamic behaviors, which is only has one method in it, will move to animator. So that gets called every time it gets moved to an animator or out of an animator. This will be called with nil. Okay? So that way you can find out whether your behavior is currently being animated or not, and by which animator. Okay? And the last thing I'm going to tell you about behaviors, really cool property, is a block called action. This block returns nothing and takes no arguments, so it's a basic block. This block you provide, you just say my whatever behavior, gravity behavior, collision behavior, whatever, dot action equals a block. It will execute that block every time this behavior causes animation change. Okay? So this is called a lot. As gravity pulls the thing down, every time it moves, even a pixel, this thing gets called. Okay? If a collision happens and it moves off, that causes it to move, this will get called. Okay? So this is a way to get in there and get involved. Now, you have a responsibility when you get in there. Don't do anything really expensive in action, or your animation will get all jerky. Okay? You do not want to do something expensive like draw too much, but you can draw a little bit, and we'll show in the demo on Wednesday, we get to the part where I'll set an action that draws a little bit so that we can see things a little better. And you can see that it's really nice to be able to set this. Okay? So this is this simple little hook to get involved with the animation that these behaviors are causing to happen. Okay? All right, so let's do this demo. All that what to look for, you can look on later. Just make sure that you actually saw this. This demo is called Drop It. I'm basically going to drop views, squares, down, and they're going to collect at the bottom. And when a whole row collects, I'm going to blow them up. Kind of like Tetris. You know, Tetris, you put the blocks in and they fit, and when you get a row, boom, the row disappears. We're going to do that. Okay? We're not going to use Tetris squares and stuff like that. This is a demo. I only have 45 minutes to do, but we'll do blocks instead. But the main thing, I just want to show you everything I can in that amount of time about animation. So we're going to make a new app here. Let's get rid of that. Don't need that. We're going to create a new project. I'm going to call this project. I'm going to go quite fast now through most of this stuff that you already know how to do. So I'm going to do drop it. I'm going to call the view controller also drop it. Okay, we'll put it in home directory developer. Here's our drop it. You know me, I always like to move these out of the way. All right, so here I have my storyboard. I'm going to use a generic UI view to contain my game. Okay, my little dropping game. I could do all this dropping in self.view here, but that's usually a bad idea, because what if I ever want to add a score or another button or something like that? I want my game to then be in a little smaller space, and you're going to want to do that for your homework as well. So I'm just going to drag out a generic UI view. I always have trouble finding it. Yeah, there it is. So I'm going to drag this generic UI view in here, and I'm going to create an outlet to it, and I'm going to call it my game view. So I'm just going to control drag out here. I'm going to call it game view, and it's a generic UI view. It's not, it's no custom thing, but I just want it to be the bounds, and I could move these bounds in from the edge if I wanted to put some other UI in there or whatever. So now I have my game view, and I'm also going to have a tap gesture. So let's drag out a tap gesture so that every time I tap on this, I'm going to add another square to drop. Okay, so I'm going to put this on my game view. Here's my tap gesture right here. Control drag this out. I'll call it tap. Okay, connect. Make some more space here for us. So every time that you tap on my game view, I am going to drop another little square that falls down like a Tetris kind of thing. Oops, oops, drop. Okay, so that's what this method is going to do. It's just going to add a view. So this is also a chance for me to show you how to create a UI view in code, which hopefully you've all done that because you've done the part of the homework that's the custom view. But if you haven't, here you go. I'm going to actually create the frame first. So I'm going to do this frame. I'm going to have the frame's origin start out as CG.0, but then I'm going to change the X origin. So I'm going to have that drop start out at the top, and I'm just going to put it at a random spot across the X. The size, I'm going to define a nice little, let's do a static const CG size. We'll call this drop size equals, and I'll make it like 40 by 40, but I'm going to make this be a static const as opposed to making it be a property or something, because I don't want to write the code right now to deal with the fact that someone changes this, because I'd probably have to redraw my whole thing to have smaller squares, right, or something like that. Which is cool, would be great to do, but it's just time constraints, so I'm not going to do that. So I'm going to have the frame size be this drop size, so that I'm creating a little drop view, okay, and that's the size I want it to be. So here I'll do my random, actually let's go ahead and do this. Let's go to here. Let's go just pick a random place along the x-axis. So I'm going to do arc4 random, and we're going to mod that by the self.gameView.bounds.size.width, so somewhere along some random spot along there. And I'm also going to make it be lined up so the drops are, in a grid. So I'm just going to divide by the drop size.width, and then I'm going to multiply by saying, oops, frame.origin.x equals x times the drop size.width. So you see here, I've divided it here. This is an int, so it's basically going to do a floor, right? I've picked a int, and then I just multiply it back. That puts it at a random spot across. And then